Hello everyone, I am Hampson-Medina here with BVHS Chemistry, and today we are going to learn how to find empirical formulas given percent composition. Percent composition of each element. Step 2, use percent composition to find mass composition. If given the option to assume a 100-gram sample, then your percent composition will be equivalent to the mass composition. You will then use the mass composition to determine the molar composition. To do so, you would simply divide each element by its molar mass. Then you use the molar composition to find the smallest whole number ratio in the elements. You then divide each element's molar composition by the lowest molar composition value. You then use this ratio to find the empirical formula, which must be in whole numbers. So here we have an example of an empirical formula problem. Example 1. A compound is found to contain 50.05% sulfur and 49.95% oxygen by weight. What is the empirical formula of the compound? So step 1, we assume that this is 100-gram sample, and then we solve for the grams, the mass of each element. So here we have sulfur, which would be equal to 50.05 grams, and oxygen, which would be equal to 49.95 grams. Step 2 in this problem would simply be to convert the mass to moles. So given sulfur is 50.05 grams, we would divide it by its molar mass, which is 32 grams per mole, which gives us a value of 1.56 moles of sulfur. And for oxygen, we have 49.95 grams divided by its molar mass, which is 16 grams per mole, which would give us a total of 3.12 moles oxygen. Now for step 3, you would divide by the lowest molar composition. So here we have sulfur and oxygen. Sulfur has a molar composition of about 1.56 moles, and oxygen we found was 3.12 moles. So simply we divide 1.56 moles by 1.56 moles and get 1, and then we divide oxygen's 3.12 moles by sulfur's 1.56 moles to find that oxygen is equivalent to 2. And then to step 4 is simply writing out the empirical formula. As evidence here, we have 1 sulfur and 2 oxygens. So here is our empirical formula for this problem. SO2. Now we move on to a little more difficult problem. This next problem is a combustion problem with a little bit more difficulty. So example 2. The combustion of 1.38 grams of a compound which contains carbon, hydrogen, oxygen, and nitrogen yields 1.72 grams of carbon dioxide and 1.18 grams of water. Another sample of the compound with a mass of 22.34 grams is found to contain 6.7 grams of oxygen. What is the empirical formula of the compound? So here, step 1 would simply be to find the mass of carbon and hydrogen, because it is not explicitly stated in the problem. So here we have carbon, which we use 1.72 grams, as that is how much CO2 is made. Multiply that by the molar mass of carbon divided by the mass of CO2, which would be 44 grams per mole, which gives us roughly let's write down here, 0.4694 grams. And then for hydrogen, here we have 1.18 grams of the water times the molar mass of hydrogen is 1 gram per mole, also divided by 44 grams per mole, which gives us roughly 0.1321 grams of hydrogen. So now we move on to step 2 of this combustion problem. Now we must find the percent composition of each element. So we find the percent comp. So carbon we found had 0.4694 grams, and so you divide that by 1.38 grams, as that is the total number of the compound, the total mass of the compound. So we find that that carbon is 34.01% hydrogen, which was found to be roughly 0.1321 grams. You divide it by the total mass of the compound, 1.38 once again, and we find that hydrogen is about 9.57% of this compound. Next, we move on to oxygen, which we see is 6.75 grams, as given to us in the problem. And you divide that once by 22.34, as that is the second sample. And we find that it is 30.215%. Nitrogen, finally, we would take 100, as that is 100%, minus the added sum of these 3%. So we have 100 minus 34.01% plus 9.57% plus 30.215%. And we find nitrogen to be roughly 26.205% of this compound. Now, step 3, we assume 100 gram sample, and then we convert our percent to mass. So there, carbon being 34.01% would be 34.01 grams. Hydrogen being 9.57% would be 9.57 grams. Oxygen would then be 30.215 grams. And nitrogen, therefore, would be 26.205 grams. Now in step 4, we find the moles of each element. Once again, simply by dividing each element's mass by the molar mass. So here we have carbon, which is 34.01 grams. Divide that by its molar mass of 12 grams per mole, giving us 2.832 moles. Next we have hydrogen with 9.57 grams divided by its 1 gram per mole, leaving us with 9.57 moles of hydrogen. Next we have oxygen being 30.215 grams divided by its molar mass of 16 grams per mole, leaving us with a total mole value of 1.888 moles. Lastly, we have nitrogen having 20.205 grams divided by its molar mass of 14 grams per mole, giving 1.871 moles of nitrogen. Now that we have our mole values, we can move on to step 5, which is divide by lowest molar value. So here we see that nitrogen has the lowest molar value with 1.871. So therefore, we would take it, divide it by every one. Here, we would equal 1. Once again, divide by 1.871, leaving us with oxygen value of 1. Dividing by 1.871 gives us a value of 5 for hydrogen. And once again, divide 1.871 out of 2.832, which leaves us with 1.5. This here, 1.5, is unacceptable. We will have to multiply each value by 2 in order to get the lowest whole number value. As we have seen previously, we must have, very important to have a whole number value. So this will leave us with a 3, with 10 here, 2 here, as well as 2 here. So now we can write the formula. So our empirical formula for this will now be C3H10O2 and 2. And now we have solved a combustion problem and also a regular empirical formula problem using percent composition. Thank you for watching this video. I hope you learned how to use the percent composition to find empirical formulas. Have a great day.